So we're going to finish up our last day of simplifying trigonometric expressions. And there was a problem in your assignment that was somewhat challenging that Haley was looking at. She's like, I'm not sure we covered an example of how to do this one. And I'm going to show you a couple of those today. First of all, let's look at problem G, and we'll look at H, I, and J. And then after that, I have the easiest problems that I could possibly give you. I discovered some easy problems to try to get you some free points on the test. How does that sound? Does that sound all right? Okay. Here we go. What do you think I do here? How do I simplify that type of expression? I'm going to distribute and multiply these out. What is 2 secant times 2 secant? 4 secant squared. And then 2 secant times 2 plus 4 secant. Then negative 2 times 2 secant. Negative 4 secant. And then negative 2 times positive 2. Good. So I multiply it out, and I hope that I just come up with something that maybe works. What goes away? The middles go away. That's nice. Then I'm left with a 4 secant squared minus 4. Now, when I look at this, I'm kind of happy because I got a squared, but I'm not used to seeing anything on my sheet that has a 4. Any thoughts what we could do with that 4? Factor it out. Well, I like that because secant squared minus 1 is something on my sheet. Which one is it? Yep, it's tangent squared. It's number 6, so I get 4 times tangent squared. Not too bad, huh? Let's try one that's a little bit trickier. Okay, for H, I'm going to rewrite this. I don't see that I have a squared anywhere. I don't really see that factoring something else is going to help. And so I'm going to take my best shot, and I'm going to rewrite this as cosine of theta over 1 times, how do you rewrite tangent? Plus, how do you rewrite cotangent? Huh. Something cancels, right? Nothing in the middle, but the cosines cancel. And so I can rewrite this as sine of theta, and I'm going to write it over 1, and you're going to see why in a second here. Plus, what's in the numerator here? Cosine squared over sine. Wouldn't it be nice if there was something that could kind of help me out there? If I see a sine squared, I either need a 1 or I need a cosine squared, don't I? There's nothing I could substitute in. But what would happen if I did this? If I found common denominators and actually combined the two fractions together? What would you now have in the numerator? Sine squared plus cosine squared all over sine. sine squared plus cosine squared? Most important identity to know. It's number 5. It's 1. Sine squared plus cosine squared is 1. Remember, Andy, you told me to prove it to you the other day. On your birthday. So we get 1 over sine, which is cosecant. I will tell you right now that you have a problem like that in your assignment. I will also tell you will not have a problem that difficult on your test. That's a little bit challenging. You might see something like that for extra credit. Let's try this one. It's going to work out very similar. Sine squared over 1 times what? 1 over cosine plus cosine of theta over 1. Nothing cancels, does it? But maybe if I find a way to combine these together, maybe something will cancel. In order to have common denominators, what do I need to multiply top and bottom here by? So, what do I have in the numerator? Sine squared plus cosine squared. And what is my denominator? Cosine. And now we have that wonderful identity. Sine squared plus cosine squared is 1. We have 1 over cosine, which is secant. You have one very similar to that in your homework. One last problem, then we'll do some really easy problems. Let's try I. Again, I don't see a squared. I don't see something that factors out. So all I can do is just try to change them to sine and cosine and see what happens. Okay, so I changed it to, I still have the cosine, I still have the sine, but I changed tangent to sine over cosine. So what's going to happen there? Yeah, the cosines are going to cancel. What are we left with? I'm left with 1 minus sine squared. Wouldn't it be great if we knew what 1 minus sine squared was? It's cosine squared. Sweet. Ready for a couple real easy problems? Within your notes, do you have a back side to your notes that maybe doesn't have anything on it? Go all the way to the very back page. And about halfway down, just draw a line and put this underneath it. You're going to go to the very last page. You're going to draw a line about halfway down, and you're going to label this even and odd identities. And I decided to add this in because these are nice ways to get some easy points, and these are important pieces to know as we move forward. And here's how it works out. I can't prove these to you guys because we haven't learned the sum and sum and difference formulas for these pieces. We don't do that in this class. So you may wonder why this is true. It just is, okay? If you want a better argument, come see me after class, and I'll show you why. But one thing we say in trigonometry is we don't like to have negative angles. Suppose you see sine of a negative x. Do you know what we do with the x? We move it out front. Suppose we have cosecant of a negative x. What do you think we do with that negative x? We move it out front. It's not the same for everyone. If we have tangent of negative x, we also move the negative out front. Yeah. It's actually already on your note sheet. Yep. And I'll show you guys where. And if we have cotangent, we also move the negative out front. So sine and tangent, cosecant, cotangent, you move the negative out front. But for cosine, it's different. The negative value just disappears. You want to know why, don't you? I'll show you. This is the best understanding of why I could tell you. Okay, and I'm not going to make it too complicated, but you guys know what sine and cosine. You guys know what the graphs look like, right? And so we'll just look at the graphs for a second here. Cosine starts up at 1, right? And it goes like this, right? Whereas sine, sine looks maybe something more like that, right? Well, we're saying the cosine of x and the cosine of negative x, we're saying that those are the same thing. Well, if you pick an x value, the output would be right here, right? Well, if I do a negative x, just back the other way, the output's the same, isn't it? It's the same on either side. But look at sine. If you pick an x value, say here, that's your output. But if you do the negative x on the other side, it's going to be similar. It's just going to be opposite value. So that's technically kind of what's happening here. So as I showed you, you have this cosine of negative x is cosine of x. Whereas secant of negative x, again, the negative just goes away and you get secant of x. So let's try two problems that are just super duper easy. You ready? And I'll put a couple like these on your to get ready for your test. This will be our first one. This will be our second one. We will do sine of negative x plus cosine of negative x plus sine of x. We want to simplify that. If you want to simplify that, we got to get rid of the negatives first. What do you do with the negative here? Negative sine of x plus cosine of x. That negative goes away. And how about this one? Just plus sine of x, right? So this negative sign, the positive sign go away. You're left with cosine of x. It's kind of a nice problem, huh? Ready for one more? You guys try this one on your own, okay? So we will do 2 tangent of negative x plus secant of negative x minus tangent of x. I'll show you what you're talking about in just a second. Okay, so you should come up with secant minus 3 tangent or negative 3 tangent plus secant. But make sure you get rid of the negative angles. Is that good? All right. So all I'm going to do is just add a couple problems like that to your assignment. To get to Jesse's question, is there ever going to be multiplication involved? If you ever add like this sine of negative x over cosine of negative x, um, what happens to that negative? So negative sine of x over that one just comes right in front, right? What's sine of x over cosine of x? So you get negative tangent. That's it. Just deal with the negatives. Okay. Yes. For people watching video, I'll build some problems like that. We won't add any problems to the homework. We're just going to add them to the study guide.